Todd Borke. I'm the Vice President of Operations at Network Center, and I have the privilege to introduce one of our other technology gurus within the organization. So this morning, Joe Dunnigan is with us. And I'm just going to read from this, and then I'm going to let Joe kind of expound on it a little bit. But Joe's the head of our application development within the organization. He's got 16 years, over 16 years of experience developing web and mobile application. He's utilized many, many platforms over that period of time. Specializes in AWS, Drupal, some Android development systems, data integration, things like that. So I'm going to back out of the way, and I'm going to let Joe walk through his presentation. So Joe, first, thanks for doing this, and if I missed anything, please add, but it's all yours.
All right, thanks, Todd. Hey, everybody, thanks for coming. I am here today to talk to you about DevOps, and I've talked about DevOps before a couple of years ago, so I'm going to take a slightly different approach today. I've got more friends. So why do I want to talk about DevOps? First, unpack that a little bit, right? It means developer operations, right? But it's come to mean a lot more than just development or developers as the years have gone by, and as time goes on, it's continuing to involve more of our processes and operations in how we develop, deploy, manage, and maintain software across not just writing software, not just writing code, but the platforms and systems that help us to support the applications that we're running. So there's all that, and DevOps really for us also involves things like change management. So we want to promote a change to our application or to our environment, right? So there's controls, there's checks and balances. We need to be able to go back and say this thing was done and there was a reason behind it, right? As we get into bigger business, that gets to be more of a thing. We have regulations that we have to adhere to, and so change management is a big deal. It's a big deal in DevOps. Infrastructure as code, it's actually where I'm going to spend a little bit more of my time today in how do we promote not just the application code that we're writing, but also the systems and services that support it, and how do we monitor and maintain change in those systems. How do we track change over time, and how do we get more and more of it into a reproducible code base? And then automation, automate all the things, right? So let's see what we can automate today in DevOps, what we want to automate as time goes on. Project management, that maybe should have been up higher in the list because a lot of things start with project management, they end with project management. It is a big part of everything that we do, right? Working with customers to build and create applications, define requirements, work through the development process, deployment, QA, beta testing, production, change over time, right? All of those things, project management underpins all of it. And then application lifecycle, right? We get an application deployed, it's in production, but then there's going to be changes. There's going to be bug fixes, there's going to be new features, there's going to be security changes over time, right? So managing the full application lifecycle. So dig into change management a little bit more, right? So we want all changes to be logged by design, and we want to make that process as seamless as possible. We don't want to have to always manually submit a request, have it go to a committee, have the committee discuss it, have the committee possibly approve it or possibly go back, for a second round approval, go through a couple of rounds of red tape, and then finally it gets approved and we can do the thing we need to do, right? Let's automate that as much as possible. Let's make it inherent in the system so that it happens without us having to think about it. And then making sure that we have the tools to support those processes and systems. I'll mention, I don't talk too much about specific tools today, but I will mention that we're really heavy users of GitLab, and GitLab helps us to do a lot of these things. Azure DevOps is a good example as well. GitHub actually is a great example for wrapping all of these different kinds of tools and processes and management together. Project management. So this is a big journey for us, and it's fun and it's painful. And the tools in particular can be a lot of fun to get to learn and understand and use. And as we learn and understand how to use them better, it opens a lot of doors for us and just helps us to be able to, do what we do better and more efficiently, right? So planning features, planning sprints, planning milestones, right? From the smallest unit of work to the largest multi-month big plan of this big feature we're gonna release, right? Having the tools in place to help us do that, to have many people working on one project at once and keeping everybody in sync, that's a big part of it. Resource management, right? Where can we slot these people? Who has the skills to do what task? Those are all questions that need to be answered and that are important to us in doing our day-to-day job. Well, I forgot to mention at the beginning, if anybody has questions, I think virtual or otherwise, especially virtual, you can be typing out those questions as I'm talking, and I'll cover them at the end. Okay, so infrastructure as code. I said I wanted to spend a little bit more time on this in particular. So what this has been looking like for us over the past couple of years as we've been kind of the evolution that we've been going through and how we think about software, how we design software, how we deploy it, how we manage software over time, right? On a larger scale in a lot of cases. The infrastructure and the services that are running that software are just as important as the code that we write in order to build software. So as time goes by, there's less segmentation between them. They're getting to be more and more the same thing, right? There's less separation between the components of the infrastructure that are running the application and the application itself. They're getting more intertwined to the point where sometimes we can't even see where the line is anymore. So talk about just some of the traditional components of infrastructure, right? And then how they relate to how we're doing application development today. So you've got your network design and architecture, your compute, your storage, and then visibility like logging and application services, right? So we talk about network design. I got a couple of networking guys in the room right now. Scary. But there's a lot of things that as IT professionals we're used to on this list, right? We talk about firewalls, we talk about routing, subnets, access control lists, giving the ability for processes and systems to communicate between each other, messaging services, which is really how do we let those services communicate with each other? How do we make sure that that's fail-safe and redundant and so forth, right? So network design it underpins, it is a core component of the infrastructure of everything we're building, right? Can't have an application without network. Same thing with compute. There's a lot of traditional ways of thinking about compute. We still tend to talk about virtual machines and instances and so forth, right? Even bare metal at times. So that traditional compute is still very much in our minds. It's part of what we do. But how we propagate those systems is definitely changing. The next one is serverless functions, and I like to talk about serverless a lot, and I saved a slide at the end to talk more about serverless in depth. But the past couple of years, as we've spent more and more time getting into serverless infrastructure and how it can benefit us, really how as application developers, how it can help us to more quickly get products to market, how we can more quickly prototype systems and understand, is this idea that we're working on going to work, right? It speeds time to market, it speeds time to delivery, and it helps us, with some things I'll talk about further. Container orchestration, something that, in a sense, we're doing, but we're not looking under the hood a lot right now in our team in particular. But when we talk about container orchestration, the big word that people would be able to relate to in a certain sense would be Kubernetes, right? In the IT world, everybody talks about Kubernetes now for container orchestration. It's essentially, it's a management plane that gives you network and compute and storage to be able to run your workloads, right? That's still pretty fuzzy, but Kubernetes or Fargate or basically just ways that we can build containers, ship them up to the cloud and have them do their thing, right? And then I mentioned messaging on the network side, but it also applies to the compute side. What this really is giving you a middle layer where one system or service can send some information, and then another, you call it a subscriber model, right? Where I subscribe to messages of a certain type, and if a message like that goes into the queue, then I pick it up and I do stuff with it, right? Could be a business process, like a transaction occurred. Okay, well, there's another system that's interested in those transactions, and it's gonna grab that message, it's gonna go and do some processing on it, and so forth. Another part of the stack is storage. We tend to think of storage as just a raw thing that it always has to be there, but really storage services are where it starts to get interesting, where I don't just have a SAN with LUNs, but I actually have a highly available, durable storage service that's spread across multiple data centers and is it's surfaced to me as an application provider, as network attached storage or blob storage, right? Where I can store any type of file, whether it's an image or a document or so forth, right? And know that that's going to be highly available, and I can access it programmatically or through traditional means. So the propagation of storage services, I would say, is another area that's helped us to rethink how we can build applications and connect storage to them in a highly available manner. And then database services, I put it under storage. It's kind of weird, but really, we do tend to end up thinking about databases as a storage mechanism because really we're storing data, right? And we're accessing data from those services. And it's interesting that over time we get to abstract more of what the database layer really is, care less about the specifics and care more about, again, programmatically or through an SDK or a CLI, how we're going to be able to get access to that data and how we store it in different services based on how we want to get information out of it. Like I'm gonna store data in a different service if it's going straight to consumers through a web app versus if I'm going to surface it in analytics for BI jobs, right? I may store duplicate sets of data in different types of systems specifically for the workload in mind. And the services that we have available to us today mean that we can be thinking about concepts like that because cost has come down so much, and really duplicating our data in certain scenarios is actually more cost effective than not doing that. Okay, and then visibility. Another area where we're always looking to improve, where we're always looking at what we can do better and what tools and services can help us do that better, right? Really, the idea is start by logging everything you possibly can, right? If there is a problem in a large production system, the best way we're gonna be able to find out what that problem is by having information at our fingertips about what's going on in the system, what was going on at the time that a problem happened, and how can we narrow down, how can we correlate together data from disparate systems in order to find the issue. And then how can we track information over time, right? The more data we have at our fingertips, the better we can understand how an application is performing, how users of the system are getting the information that they need. And so visibility is a key component to that stack. Oh, now I have a couple of pretty pictures. So this graphic is really what this is at the end of the day is just a web application or a website, right? But it's a highly available and durable website. And the reason I want to look at something like this is I used to build these 5-10 years ago from scratch, where I would build the management plane for them. I would build the scalability of the application servers. I would build the scalable database service, the scalable storage, right? I'd have to do it all by hand, and it was a long, cumbersome process and difficult to manage and maintain. So this is where infrastructure as code first starts to really help us. Me personally, from on a personal level, I can really attest to the fact that the time to market for me to do these things has increased exponentially. So this, we are able to, if we look at this, we've got, it's like a common application stack, right? We've got a firewall, we've got a content delivery network, and then we have a load balancer that's in front of a bunch of application servers, one to many, right? Possibly auto-scaling based on traffic needs. You've got file services, so you have durable file storage for, let's say, content, right? Again, images, documents, et cetera, that, let's say this is a WordPress site. You've got content editors that are going in and they're writing articles, they're uploading photos, et cetera, right? If we're running a multi-tier application server, then all of those app servers need to be able to get to that same image, regardless of what server the consumer is hitting. So you've got this durable storage underneath it, and then you've got the same durable database storage. So we're now able to do about 95% of this in code. So instead of me going and clicking around in the management console or sending commands saying, spin me up a load balancer, spin me up application servers, and I'm going to go into the application servers and I'm going to configure them and I'm going to clone one and I'm going to maybe clone a couple of them. Now I'm going to go and set up my database service and I'm going to provision the storage I need for it. I'm going to set up a scalable storage system that spans multiple servers, possibly multiple data centers, right? A lot of work going in there. Now I can say, I need this service, I need this service, I need this service, right? From a CLI, I can say, add storage, right? And that goes into a template, which technically is YAML or JSON code, which gets stored with the rest of my application code. And then when I go to deploy, it provisions all of those services for me, makes changes to them as I make changes to that, that code template. And so I can store all of this information in a repository where changes can be tracked. So you see there's a couple of things, like there's security groups down there that are allowing the application servers to access the storage and the database. That's tracked in code, right? So if I make a change to that security group that says, not only do these application servers need access to this, but this other ancillary service also needs access to my storage, I can go back later and see, yes, a change was made to that security group. It was made by this person at this time, and there was this reason behind it, right? So we have change management inherently built into the system. And again, this is just a web app, so it's not too crazy a thing, but if we go and we start looking at a more complicated system, so this is roughly, this isn't a complete picture, but it's probably 70% of a system that we built and run in production now. And you can see how as these systems grow, there can be a lot of added complexity happening in them. And for us to go and provision all of these services independently would be time consuming, error prone, and probably the biggest point that I will get to is being able to replicate this across multiple environments. So I don't just have production, but I also have staging and QA and dev, right? And I need all of them to be the same thing so that if I promote a change to QA and it gets tested and is good, I know when I promote it to production, it's going to be the same, right? I'm gonna get the same results no matter what environment in. And I want those environments to be as isolated as possible, and I want them to be as similar as possible, all the way down to the firewall and the subnets and the ACLs and the VMs and the storage, right? All of the infrastructure involved in it. So, and that's also a really fun, cool project. So like I said, reproducible, right? The more we can package into code, the easier it is for us to replicate environments and to know that when something is tested in one environment, it's going to test the same in the other environment. The closer we can get to that, the more time we can spend building features, less time we can spend fixing bugs and investigating unknown issues. So automation, I've talked about some of the pieces of automation, right? The idea is that automation can be inherent in every aspect of how we're building and deploying services and software, right? So we want to automate application builds. We want to automate deployments. One thing that we have been working on is we can automate deployments when we promote changes, say from QA to prod or from dev to QA, right? When that change is submitted and somebody approves it, the code automatically builds and deploys into the environment, right? But we also want to look at how can we automate changes to, say, a security vulnerability in a third-party library that's being used in one of our projects, right? It's a common scenario, and there's still a lot of manual effort that can happen there. But one thing that we're working on is, let's say, a nightly process that checks out the code. It looks for any vulnerabilities that exist in any libraries. If those exist, it applies the change. It downloads and installs the new package. It builds the platform, spins up a complete environment with all of your network, storage, compute, right? A completely isolated network, builds the entire platform, runs automated test suites. Everything checks out, it's good, it checks in its changes and promotes them to environments automatically, right? So that's a thing we're working on, we're hoping to get to. It's pretty exciting, yeah. So one of the things that I take out of where DevOps has been headed for the past 5 years and where we see it going in the next 5 years is that a lot of our work across IT is getting more application-centric, right? When we think about what are we as IT, what's one of the main things we're trying to do at the end of the day? What are our users doing, right? What are the systems that we're building providing to our users? And a large part of the time, it is application delivery. It's our users are accessing applications, and we are building the stuff under the hood that allows those applications to run and do their jobs for their users. So thinking about our jobs in an application-centric manner, from the top down, saying, this is our end goal, this thing needs to run and do its thing, right? What are all the components underneath it that make that happen, and how can we pull them all together and make them one cohesive unit? Yeah, that's where we're going. Okay, cool. So I said I wanted to talk a little bit more about Lambda. So we've done some really cool things with serverless computing in the past couple of years. And we've been able to realize some of the benefits that we're already gaining and insight into benefits we can gain in the future. So to try and break it down, really serverless computing is just I can write code and deploy it, and all of the underpinning infrastructure is taken care of for me. So network's taken care of, storage is taken care of, compute, right? All of those things that are needed for code to run are taken care of for me. So I just have to worry about the code. So say it's some sort of event that happens, like a user uploads a document into storage, and that needs to trigger a workflow for something to happen, right? Serverless computing can be a use case for that. But what we specifically, we have an application that provides identity management and profile services for roughly 500,000 users right now. So it's a pretty big app. It's a pretty big set of services, really, is what we should call them. And I would say all, if not close to all, of the computing that's happening there is serverless. So I wanted to think about what would it take, what did it take when I had to build these kind of systems traditionally? There's requirements like it needs to be running in at least 2 data centers at any given time, right? And even within a data center, it needs to be running on at least completely disparate hardware. So I need to have N number of application servers, at least 2 spread across 2 physical machines in a data center, replicated in another data center. The network needs to be able to handle talking to both of those simultaneously, getting to the underlying storage, and knowing that the data is consistent across all of that. So, just thinking about that traditional, if we just had 4 servers across 2 data centers, each with some compute and some storage, that's a lot of infrastructure to manage and maintain, to build and then to keep it running, right? But we get all of that out of the box with serverless compute. It's automatically in multiple data centers. It can scale to millions of requests a minute, possibly a second. And we haven't begun to hit those limits yet, I don't think, but we are processing a lot of data through Lambdas now. So I know we're doing roughly 250 requests a day last time I looked, and our cost is roughly 2 cents a day on that workload. And we're doing some pretty high profile stuff in there, really just as far as, again, like I said, identity management and profile management. So, security is top of mind, data durability is top of mind, right? We're also, if I poke back at that bigger graph a little bit, we're doing things like we're sending out emails to users, we're sending out texts to users, push notifications, a lot of cool stuff that's almost all happening serverless. So it's a fun area to be working in, and over time we're doing more and more with it. And that's me, DevOps for everyone. I hope over time that, especially at NCI, that we'll get to work more together across disparate teams on these types of projects where we have a mixture of infrastructure and application development and take it into the future. Anybody got any questions for me? I don't think I see any on the screen. I would probably take some of the use cases that we've had success with now today. But I don't know. You stumped me already. That's a good question. I would say I see similarities because we're pushing the same workloads to serverless that traditionally we pushed to servers. You know, it starts out as small, let's say, isolated units where it's a single threaded process, right? Some piece of data, I guess, ETL, data transform processes are probably a decent example where, you know, we've worked with some pretty big, robust ETL engines in the past, right? I know you have, Todd. But we're doing more and more of that with serverless these days, and we're able to do it in an event-driven manner. So instead of doing big batch processes of data, we're able to do it as the data is coming in, and we may push data to 3 or 4 different areas for archival purposes, analytics purposes, real-time analysis purposes, right? Because again, like I mentioned earlier, there's no one database service that can fit all the different needs we have today for our data. So that's a good use case for serverless where a piece of data comes into, say, a NoSQL database that's right on the front, right, serving web traffic. We'll shove that into an S3 bucket, into blob storage, and then that'll trigger another event that sends it over to a relational database, and could also possibly trigger a third event that will send it into a data warehousing solution, right? So, yeah. All right, good deal. Hey. Yeah, and I think the effectiveness of serverless is a good piece of that, because again, we're paying fractions of pennies, the smallest fractions of pennies imaginable, in order to process a chunk of data, right? So there is definitely thoughtfulness that goes into designing a system like that, and it has to be designed with intention. Like we're not trying to build a one size fits all necessarily. We're trying to build it to purpose. But I think the best example I can give is that we are not able to. We want to serve single digit millisecond traffic to web users, to application users, but we can't serve that same data to analytics workloads. So we need a different solution, right? So at a certain point in time, we need the high availability and durability of, let's say, a NoSQL database that can be spread across multiple data centers, and we can rely on the durability of the data and the eventual consistency of the data, right? Where reads are more important to get out the door than writes are to get in the door. It's that specific type of workload where we're serving high volume web traffic versus I want to look at a 6-month historical spread of what my users were doing when they clicked this button or when they went to this page, right? Or how many dollars were spent in Q1, right? Those are the types of different workloads where we're seeing the value in not trying to get one system to do all the things, but using the different systems to do what they're best suited for. And I don't disagree that durability between those data silos is important. And the best way we're able to accomplish that right now is by moving the data in real time, to know that we never have to go and process a big batch like in the middle of the night, right? We're going to move that data in real time. We're not going to worry about how fast it gets from point A to B, but we're going to worry that the messages are there to be picked up and that they do get picked up, in a timely manner, right? Eventual consistency. But I think that's how we're solving the problem right now. But certainly, it's an area where we're spending a lot of time and constantly improving. Hopefully that answered the question. Anybody else? Cool. All right. Thanks, guys. Appreciate it.